A is directly proportional to B. So A is equal to K times B for some constant K. And our first step is to figure out what that constant of proportionality is. Plug in A equals 26 when B is equal to 49, and dividing both sides by 49, we find that K is equal to 26/49. So we found K, the constant of proportionality, and that's very crucial. Now that we know that, we can answer the question that they asked us. Find A when B is 37, because now we know that A is equal to not just any old K times B, but 26/49 times B. We can answer any question now that we're armed with this, and we're told, oh, when B is equal to 37, then substitute 37 in place of the B here. And so this becomes 26/49 times 37. And 26 times 37 is 962. So A is equal to 962/49. And we have solved this equation for A here. Find A when B is 37. When B is 37, A is 962/49. Okay, now for problem 85. Y is directly proportional to X, and Y equals 1.54 when X equals 7.92. Find Y when X equals 5. Well, to begin with, Y is directly proportional to X, so we know that Y is equal to K times X for some constant of proportionality K. We're told that Y is equal to 1.54 when X is equal to 7.92. And so we can solve for the constant of proportionality K. Just divide both sides by 7.92. And we can find K. K is equal to... It's best to simply leave it like it is, probably, as 1.54 or 154 divided by 792. No need to simplify it further. We can use it like that. Anyway, that's the K we can use. Let's see what it is dividing it, but usually it's better just to leave it in fraction form. Well, that's, you know, 0.194444. But it's better to leave it in fraction form so you don't have to write so many digits of a decimal expansion. So we're going to use this for our K. Now find Y when X is 5. Well, Y then is going to equal K times 5. And let's calculate that. So we have 154 divided by 792 and then times 5. And I get 0.97, 0.97, and then a bunch of 2's. Now rounding this off to the nearest hundredth, we'll just truncate it right there, and that's our solution, approximately. When x is equal to 5, y will equal approximately 0.97. Finally, let's look at problem 86. It's almost the same problem that we just did, except inversely. Instead of directly proportional, now we're talking about inversely proportional. And so, here we go. So instead of y equals kx, y is equal to k divided by x. So when y is 1.54, the other side became k divided by x, and x is 7.92 here. Okay, so now we need to multiply both sides by 7.92. So times both sides of the equation, and you get 1.54 times 7.92 equals k. And that number is 1.54 times 7.92, and we get 122, oh no, I'm sorry, 12.20296. Don't round off this value. You want to keep all the precision that you can in your constant of proportionality. Okay, so now we can answer the question, what is y when x is 5 in this case? And so we get that y is equal to k, this value 12.20296 divided by x is 5, and 12.20296 divided by 5, and we get 2.440592. If we round off to the nearest hundredth, we just truncate this number, and we end up with y approximately equal to 2.44. When x is 5, y is approximately 2.44 in this inverse proportion relation.